And now, a storybook conversation. Please welcome Vicki Cobb, author of the Robert F. Seibert Honor Book, I Face the Wind.
I'm very happy to be here today, and I'm thrilled to share one of my books for young children, I Face the Wind. And it's a different kind of book. It's not the kind of book you read in one sitting. It's a book designed primarily for pre-literate children to be read to them, and that the reader reads a few pages, which then asks a question which can be answered by the child doing something. Then you come back to the book. And in the book, I give instructions on how to prepare for the reading. And I explain that the whole process is to have the child make discoveries, because I have discovered that young children are intellectually very curious, and if you present concepts to them in a sequence and you reinforce them with activities that answer a question that leads to another question, you can ultimately bring them to a non-intuitive, very difficult concept. So this book is about the wind. And if you look at the pictures, you'll see I have a wonderful artist for this. I'm trying to fool people into thinking this is a picture book that you read like any picture book, which it is. But it's meant to be interrupted, and I'll show you how I set that up. Ever face a strong wind? Your hair blows away from your face. You could lose your hat, and if the wind is blowing hard enough, you may even have to walk at a slant. You can't see this force that's pushing you, but you can feel it, and you can see what wind does to other things. It makes dust swirl in a circle. It makes flags stick out straight and flutter. Can you name some things you see the wind do? Go outside and watch. Leaves on a tree shake. A kite stays in the air. I love this one. An umbrella turns inside out. Add your own ideas to the list. Why does the wind push you? You can discover why by asking questions and doing things to get answers. Here's the first question. What is the wind made of? Now, I asked that question because it's about prior knowledge, but I have yet to find a 3-year-old that doesn't automatically say air. They know the answer. So on the next page, I reinforce that. I don't patronize my reader. Wind is made of air. You can't see air, but you can catch it. Here's how. Open a large plastic bag. Make sure there are no holes in it. Pull it through the air so it puffs up. Normally, I use those very inexpensive grocery bags, but they may be politically incorrect, but it should be a fairly large bag, just about that size. Twist it closed to trap the air you caught. If it is closed so that it is airtight, you can squeeze the bag with the air in it and feel the air push back at you as you squeeze. Now we come to a conclusion on the next page. I'm going to give them something to think about, because the whole thing with air is that you can't see it. Air is real stuff. It is just as real as this book or a bowl of soup. Like all real stuff, air is heavier than nothing. How can you weigh air? You can't weigh air like you weigh yourself. It is so very light. You can weigh air by doing an experiment. Now here is where we do a little bit with apparatus, which is part of what science is. You have to find a device that you can use to weigh air. So I like to find things that are usually around the house. Actually, in my house, I try to throw these away and replace them with better ones, but my husband doesn't, so I always can find it in his closet. Okay, so here is one of the activities in the book. You will need a coat hanger, a pencil, 2 identical balloons, or large zip-closed plastic bags, and tape. 1. You hang the coat hanger on a pencil. You lower one end of this hanger. It's kind of jiggling, sliding along the pencil, and you lower it, and you'll see it swings back and forth until ultimately it comes to rest. And if it's a well-designed hammer, it finds its own center of gravity, so it will come to a rest where it's balanced. What happens after the hanger stops swinging? When it comes to rest, it is perfectly balanced. You can weigh things on a balanced hanger. Tape an empty balloon or zip-closed plastic bag to each side of the hanger. You know, I don't like to interrupt the narrative by saying they should be equal distances from the end, but the picture shows that. I want to keep their attention so we stay on point. And if they try it, they don't put it equidistant, maybe they'll get the wrong results, but that's okay. Then you should know that you can go back and correct it. It's not the end of the world. The hanger is balanced because both balloons weigh the same. Now take one balloon or bag off the hanger and blow it up. Tie a knot in the balloon or zip the bag closed to keep in the air. It's another thing I didn't put in here is that it's very difficult to tie a knot in an inflated balloon, but a grown-up can do it. Kids can't do it. So it's implicit. I don't want to interrupt the narrative to dot every I and cross every T. Tape the inflated balloon or bag back onto the hanger. What happens when you hang it on the pencil? The hanger is slightly tilted again. It is tilted only a little bit because air doesn't weigh very much. Even so, the side containing air is heavier than the side that has the empty balloon or bag. This proves air has weight. Now, I don't get into gravity in this book. As a companion book in this series called I Fall Down, which deals with gravity, but gravity is also an invisible force. So you have to deal with it separately. You know, stay on focus with this one thing. We're going someplace. But the weight of air is only part of the reason that you feel the wind. Air is made of a gazillion tiny balls floating in space. These balls are so small that they can't be seen. They have to be imagined. So now I'm going to use a little scientific terminology, and I'm going to give them a word from that because that's necessary for their comprehension. But I don't go into great detail. I just give it a name. And in scales of measurement, the lowest scale of measurement is the nominal scale, which means it has a name that makes it real. These little balls, they are called molecules. Wind is made of moving air molecules. Now, the next step is to make a little laboratory because you want to do a demonstration to see how a ball might behave. But you can't use a molecule as the thing you demonstrate with, so you do what a lot of scientists do. You make a model of what's happening, and you understand the concept because you use objects and materials that are within the realm of the senses. So, we go back to imagining. Imagine that a ball is like a single moving air molecule. Sit on the floor and roll a ball so that it bumps into your leg. Can you feel it push against you? Roll it quickly into your leg. Roll it slowly into your leg. Which makes a stronger bump? Okay, so now you're going to get the idea that the speed of the air is a factor. But now let's see. Let's apply the concept in another way. How can you make air molecules move? Wave this book. The book pushes against the air molecules and starts them moving. Then they push on you and you feel it. Fanning myself. Move it slowly. Move the book quickly. Which wind is stronger? We're getting into what's called the ordinal scale, which is ranking more or less. There's a lot of science behind this. Are there other ways that you can make wind? Blow air out of your mouth. Wave your hand in front of your face. Be an inventor and make your own kind of air movers. Kids are always interested in superlatives. They want like the Guinness Book of Records. So what's the biggest wind? Have to answer that. The faster the air moves, the stronger the wind. The fastest winds of all are in a tornado. These winds are so strong they can lift a roof right off a house or make a truck fly through the air. One of the softest winds is your breath. Put your fingertips near your nose and feel your soft breath. Finally, if you got the idea, I think it's worth celebrating. So here's my way of summing it up at the end. When you face the wind, gazillions of moving air molecules collide with you. That's why you feel the push of the wind. Yay! And so you can see the arc of what I do in my books. I begin with a phenomenon that connects this phenomenon to a child's life so they know what we're talking about. I then ask a question which makes them think about it in a different way. The question is carefully structured to lead to something else. And finally, I tie it back to the original phenomenon or apply it to something else that they may have witnessed. And now I'll ask for some questions. Thank you.